Good morning, on and all present here. I'm Nandiniti. I'm working as an assistant professor in SNS College of Technology, the Department of Computer Science and Technology. Today we are going to see a topic on what does GANs training in the subject generative AI. So first of all, we are going inside and problem statement. How we are understanding this generative adversarial network loss function with the help of challenges because the generator and discriminator have an opposing objectives that are optimizing these simulations. First of all, so how a generator has been creating a fake data, so how the data has been loosed, how we are opposing it, how these loss functions are being guided, learning during GANs training. These are all we are going to see in this. First one, we are going to empathize this. So this training generative model is very difficult because we need realistic data generations. So we don't always have labeled data. So data may be labeled or may not be labeled. So this traditional models are failed to capture the complex pattern. So we need a training method that can learn directly from data and improve the continuity. So this understanding the data set characteristics, understand the distribution imbalance, identify the ethical risk. These are all the things we are empathizing here. Next one, how we are understanding or defining this problem. So it is a very high quality synthesis human faces that are visually realistic and diverseable without any individual. So this problem, how we can train a model to generate a realistic data without explicit defining the data distributions. Challenges in GAN training, no direct loss function or generator. We need to compare real versus fake data so much, how it is stable issue during the training. These are all the phases we are defining or understanding here. Next one is an ideate phase. In this ideate phase, we have three different stages. One is architecture ideas, loss function design, optimization strategies. So this architecture ideates is, so we have some conditions like conditional GAN, VGAN, DC GAN, etc. So in this loss function design, standard GAN laws, Hing laws, Westerstian laws, like this losses have been there. In optimization stages, learning rate schedules, RMS probe, add up. These are all the ideate phases we have. So in this ideate phase, two networks like a generator which produces fake data and a discriminator which classifies this real or fake has been given. So idea behind this generator tries to maximize the mistake of discriminator. So this discriminator tries to minimize the classification error. These are the two difference between these generator and an inspirator. Next one is a prototype. So in this prototype, a sample real data has been given. It is sent into a noise and it has been detecting the fake images. Then this it is trained, it is discriminated, generated, and at last it is given. So for this, train the discriminator so that we are giving an input as real data plus fake data to generate it. Output will be probabilistic real or fake. So the goal is correct classification. Next is train generator. Generate a fake data, pass through discriminator, update the generator to fool the discriminator. These are the process repeaters iteratively. Again, again, and again, we are training this process. So by training this process again, again, and again, we get a real image by generating it. So we can easily find these fake images. So next is this algorithm CAN training algorithm is shown as real data X, noisy data is Z, generates a fake data G of Z, which is a discriminator. We use a loss function of D, which is log D of X plus log 1 minus D of G Z. Update D, we are training this generator, loss G is equal to log of D G of Z. So we are updating this G. So at last we are going inside a phase of testing phase. In this testing phase, many visualization inspects, FID scores, inception scores, perceptions recall, how this phases have been fixed stage by stage, how it has been modulated, how it been trained. So this generator produces high realistic data. A discriminator becomes very strong. The challenges here are mode collapse, training instability, sensitivity to hyperparameters, which improves DC-GAN, W-GAN, and conditional GAN. So these are all the things we are seeing here. Thank you so much. This GAN generates an adversarial learning process where two networks continuously improves each other to find this. Thank you.